A very good day, dear students. So, as you know me, I am Shomudeep, your faculty for the subject of robotics. Now, here we are with the fourth session. In my previous session, we have studied about the introduction of robotics, why we need to study robotics, how we need to study robotics, how much we can do in these sessions of all, and we have also studied the types of microcontroller. Now, going further, what we are going to study. So, our target is to get into projects. Our target is to know how to build those projects. It can be some minor projects, it can be some major projects. Okay. Now, to reach the targets, we need some prerequisites. There are some pre-required knowledge of some of the topics or some of the devices or some of the chips, microcontrollers, anything you can say. So before going into all the sensors, before going directly into the microcontrollers, now we need to know, as I am again and again, time and again, I'm repeating the word microcontroller, what else we can know about that. After that, we'll be learning how to control it, because the name itself suggests microcontroller, right? So let us get into the main part where we are going to study about the microcontroller. Okay. So here we are talking about microcontrollers. Now, if you see over here, what I have talked about is a microcontroller, and specifically, we'll be talking about Arduino atmega328. Now, what is this atmega328? It sounds somewhat technical. Yes, it is technical. We are studying the most technical topic after all. Now, this atmega328 is basically the IC, or the integrated circuit. That's what the acronym IC stands for. That is present in the Arduino microcontroller. Now, how it is responsible or why it is responsible, we'll come to that. But try to understand, if you take a microcontroller, just for example, Arduino. Why I'm taking the example of Arduino? Because we are going to start off with the microcontroller called Arduino, because it is simple to use, yet it has vast number of applications in real time. So we can build many projects, numerous projects, using the microcontroller called Arduino. So when we are talking about Arduino, we must talk about atmega328 also. Now, this atmega328 is basically the IC that is present in the Arduino board. Now, let us move further and let us put back this beautiful robot over here, and let us move further to see the IC. So this is how an IC looks like. Now, this diagram must be very familiar to all of you. Okay, you must have seen at some point of time this diagram to be present over some textbook or somewhere else. Now, this IC basically stands for integrated circuit. Now, what is this? The integrated circuit, or IC, is a small electronic device. Okay, a very small electronic device that is also known as the microchip or computer chip. So in general language, people might not understand what IC is. If you tell them, please give me an IC, they might not understand, but they will definitely understand the term called microchip or computer chip. Okay, that's for sure. All right. So what it is made up of? The element is basically silicon, from where the name Silicon Valley is present. Now you get that. Okay. So it is made up of many interconnected electronic circuits, dear students. Okay. Now, what do you mean by electronic circuits? If you are from the stream, if you have any knowledge of these parts, then you would know something called the logic gates, right? They are types of circuits which performs or which allows us to perform a definite set of operations, right? So there are the AND gate. You might have studied them, OR gate, NOR gate, right? NAND gate. So these are many kind of circuits. Now, these circuits can also be put up. These circuits can also be arranged in such a format, okay, to perform a definite, very specific set of instructions are given, how electricity will pass, and how operations were going to be performed, right? So it is made up of many interconnected electronic components. Now, what are those components, dear students? They can be resistors, they can be capacitors, they can be transistors, etc. Okay. Now, these components, they are basically etched into a thin semiconductor material. See, what is this semiconductor material? These are basically partially conducting materials. They are made up of the silicon. Okay, from where the silicon very names gets it named. Okay, now this is how it basically looks, and it has many pins. Can you see over here? It has many pins, 28, 48. These are the specific number of pins. They are basically present in an IC that are basically used. See, this is how the atmega chip looks like. Okay, specifically I'm talking about the atmega328. All right, so it is a single chip microcontroller created by Atmel, and that's where its name comes from. Okay, so it is a member of the Mega AVR family and has a modified Harvard architecture 8-bit RISC process code. Okay, so there is a process core for every microchip or every computer chip or every IC. So for this one, for atmega328, we use the Harvard 8-bit RISC processor code. Okay, now let's not get into great details about these things because we don't need to study ICs specifically in this session, dear students. Okay, let us keep it for the electronics engineering part, okay, or instrumentation engineering part, right? What we are going to study over here, we are here to study robotics. So let's use this microchip in such a way. Now we might ask, sir, then why we are studying this, we are having this session about this microchip? Because you see, everything you use, you must know, even not a great deal, but at least the basics of it. Okay, so this diagram is very important. All right, very important diagram. It's the pin out diagram. What do we mean by pin out diagram? This pin out diagram, basically, if you see this photo, this image over here, we have many pins over here. This one pin, 2, 3, 4, 5. So every pin has its purpose, right? Now, what do I mean to say when I say every pin has its purpose? Basically, every pin has its circuit related to it, a circuit connected to it, right, students? So those circuits are specifically assigned some functions. Okay. Now, if you have seen, obviously you have seen socket and plug, right? You've seen socket and plug. Okay, the sockets have two points. All right, one we can say the positive, one we can say the negative, just for your understanding purpose. Now you see every pin has its own function, right? Similarly, let me just show you the full image. Yes, so similarly, you see every pin has their own function. So if you see the first one, it's called the reset, right? Pin 1, PC6. I'll tell you what this means, don't worry. Okay, then comes the digital pin 0 or RX. RX stands for receiver pin. Okay, then comes digital pin 1 or TX, that is the transmitter pin. So these are very important, receiver and transmitter. Okay, then comes digital pin 2, digital pin 3, PWM. Dear students, PWM, very important term. What do it mean? What does it mean, PWM? PWM basically stands for pulse width modulation. What is pulse width modulation? I'll tell you, don't worry. Very important function, very important function. Remember the name. Then comes digital pin 4. Then the VCC. VCC stands for basically the plus voltage. See, every 2-pin things, we need 2 voltages, right? What do I mean by 2 voltages? Basically, one must be the positive part, one must be the negative or ground part, right? So here we have two types of pins. One is the voltage pin, that is either plus 5 volt or plus 3 volt, plus 3.3 volt. Beyond 5 volt, we don't need beyond 5 volt for any of the microchip. Okay, so that is the positive voltage, and the ground is the negative part. So these are the two connection wires, right? The connection pins. All right, you can also see a ground over here, right? Just opposite to the VCC. Then below the ground, there are the crystal pins, PV6 and PV7. Okay. Then comes digital pin 5, digital pin 6, digital pin 7, and digital pin 8. Okay. Now, if you go, these are 14 pins over here on over the left side. And in the right side, if you see, again, there are 14 pins. So in total, of course, you might be wondering, in total, it is 28 pins over here at atmega328. Okay. We have the digital pin 9, digital pin 10, and digital pin 11. What is common in three of them? Three of them are the PWM pins, right? Pulse width modulation pins. Very important function of an IC. All right. Then comes digital pin 12, digital pin 13. Again, there's a voltage VCC pin. Okay. Then comes the analog reference, the ground again, and there are 6 analog pins. If you see, why 6? From 0 to 5 it is present. Analog input 0, analog input 1, analog input 2, analog input 3, analog input 4, and analog input 5, dear students. So these are the pin out structure for the atmega328. Okay. Now how they are denoted? If you see the diagram again, they are denoted like PC6, PD0, PD1, PD2, PD3, PD4. Then comes VCC and GND. GND for ground, VCC for the plus voltage, that is plus 5 or plus 3.3 or whatever it is needed. Then comes PV6, PV7, PD8, PD5, sorry, PD6, PD7, PV0, and again, the same manner, the right pins are also denoted. So this is how the pin configuration of the atmega328 is like. Now you see port A, that is from PA7 to PA0. Okay, the port A, it serves basically as analog inputs. Analog input means digital input. Try to understand what is the difference between analog and digital input. If we talk about analog input, they are basically continuous input. Okay, all the values continuously. Okay, it's a continuous set of values 0, 1, 2, 3, 4, and in between also, not 0, 2, 3, 4. In between also, it's a continuous set of values. Okay, continuous range of values. But digital input, while digital input is basically, we can say they are binary. Okay, why binary? Either on or off. Right? They are not continuous like the analog. Analog has a huge range of values, not like the digital. Okay, so port A, they serves as, port A means analog, A for analog. Okay, it serves as analog inputs for AD converter. AD converter, dear students, they're analog to digital converter. Okay, so it also acts as an 8-bit bidirectional IO, that is input output port, if the AD, that is the analog to digital converter, is not used internally. Understood? Okay, that's for PA7 to PA0. Okay, then comes port B. What do you mean by port B? PB7 to PB0. See on the left side, PB7 to PB0. Okay, and port D, which is PD7 to PD0. Understood? Now these ports, they are 8-bit, again bidirectional IO ports, that is the input output ports. Now their output buffers have symmetrical drive characteristics with high source and sink capability. Source means from where it emits. Sink means from where it goes, into where it goes. Okay, all right. As inputs, these are pulled low If the pulled up register are used, it also provides various special functional features of the atmega 328. Okay, so these are the pins. Then comes port C, which is denoted as, of course, PC7 to PC0. Now, port C is an 8-bit bidirectional output, input-output port. If the joint test action group JTAG, which the acronym stands for, interface is enabled, okay, let's not go into great details into it. Just try to give it a read through. Okay, all right. The pull-up registers on the pins, where is the pull-up register present? PC2, okay, PC3 and PC5, they will be active. And then, dear students, after all this, we have the VCC, that is the digital voltage supply, okay, or 5 volts, what we supply generally, and GND for ground operations. Okay, then comes the reset. Now, it is a reset pin which is utilized to set the microcontroller atmega328 to its primary value. So whatever values has been stored when the microcontroller is used, again, if we press the reset, we give the supply to the reset pin, it will again set. That means if we provide the necessary supply voltage to the reset pin, basically, that means setting the reset pin to be on, then we have a reset value, that is the primary value, okay, or unassigned value, whatever we have stored, we get it back. All right. Then the extol one, it is an input for the inverting oscillator amplifier and input to an internal clock operating circuit. So timer is basically very important thing whenever you are going to learn about robotics, whenever you are going to learn about microchips or such as atmega328 or atmega32 or some kind of microcontrollers, you will definitely learn about timers. Okay, I'll tell you in the future also in the further classes. Don't worry about it. Okay, then comes extol 2. It is an output from an inverting oscillator amplifier. Let me show you it fully. Yes. Then comes a VCC. It is a supply voltage pin for AD converter and port A. That means analog to digital converter and port A. It must be connected with VCC, of course. Then comes ARF. That is the reference. It is an analog signal reference pin for the, as the name suggests, for the analog to digital converter. Okay, so these were the pin configurations basically. I hope you all have got my point. Okay, so why this was necessary? So this is a very short, this is not a long session. Okay, it was a very short session. My motto for this session, dear students, was just to give you the basic knowledge about what we are going to use. We are going to use atmega328 because we are going to work on Arduino primary. But what is it? What is its function? That's what my motto was, to give it to you. Okay, I hope you have enjoyed the session, and give the session again a read through, and we'll be meeting in the further session with more interesting videos, because now we are totally moving into Arduino microcontroller and we will be knowing about the architecture. Trust me, it is very, very interesting there. Okay, when you are going to learn, because I personally, when I learned, I found it utmost interesting, the architecture of the whole Arduino microcontroller, how to code and make different projects, let it be minor or major projects. Very, very interesting. Now we'll be totally moving into the core of the session, dear students. Do not miss out for any session. See you again in the next session. Thank you very much.